Let's see this virus in action. We will first build the virus. And also, let's build the infector tool. Then, let's infect the PWD program. In another terminal, let's run netcat and listen for incoming TCP connections. I want to make it feel more realistic by opening a terminal on my Mac outside of our development container to simulate remote connections from a different machine. Before we do anything, let's run ps to show the currently running processes on the infected machine. Right now, we have the zshell process as well as the ps command I just ran. Now, let's execute the infected program. And the terminal on my Mac has access to a shell for the Linux development container. It looks a bit weird because it's raw I/O over a socket. We can follow these steps to promote the shell to a fully functioning bash with command history and colors. First, let's upgrade our shell to bash. And this is how we get our prompt back. Then, let's background the current shell. We also need to update the local terminal line settings. And then, let's get our color back. Let's head back to the victim machine and see the current running processes. And indeed, we have one more shell process that is being used by the attacker. Pretty cool. This shell works just like what you would get when you connect to a machine via normal means like SSH. We can even spawn a Z shell on top of this. You get full command history and a fully functioning Vim editor. You can poke around just like your own machine. As you can see, as soon as the infected program is run, a reverse shell was spawned and gave an attacker basically complete control, just like a normal user. If the same reverse shell virus infects a large amount of machines, the attacker can potentially build an automated service waiting for infected machines to connect, and then drop more viruses on them. I hope you are having fun and get a chance to test this virus. In the next video, I'll show you how a fileless virus works.